So Ernest Rutherford, who was a physicist from New Zealand, is the man responsible for coming up of the idea of a nuclear atom. Is the plum pudding model correct? You know, that chocolate chip and nut cookie model, is that correct? Well, you guys already told me that the proton and the neutron are in the nucleus, so obviously the answer to this question is no. It's not correct. And it's Ernest Rutherford who figured that out. When he did his experiment with the gold foil, Rutherford began his work thinking that the plum pudding model was in fact correct. He had no reason to assume it wasn't. He was just trying to validate that. So he set up this crazy looking experiment that should be in everybody's knowledge bank or data bank with gold foil. So he had a chunk of lead here. So we have a box that's full of lead, and the lead had a tiny opening in it, and inside the lead box, otherwise known as a lead pig, were alpha particles. That's a Greek alpha. It looks like a little fish. It's the first letter of the Greek alphabet. And alpha particles are helium nuclei. They're very heavy, and they're positively charged. Rutherford was shooting the alpha particles, that's the little fishy thing there, at the gold foil and expected all of them to hit right across from where he was shooting them. Now, mind you, he must have had some sort of idea that this wasn't entirely going to work, because his detector was circular. I mean, it went all the way around the gold foil and to the lead. What Rutherford found out is most of them did hit that spot, but some of them went that way or that way. They were deflected a little bit, and some of them bounced nearly backwards. Rutherford is said to have said something like the results were as if a cannonball was shot at a piece of tissue paper and it came back and hit him in the face. This was so unexpected that he figured this gold foil, which was just a few atoms thick, would allow every alpha particle straight through. It would be like pointing a gun at a piece of cookie dough. It would go right through. It wouldn't stop the bullet or wouldn't stop the BB or anything else. So Rutherford was astonished. So he was trying to figure out what could possibly have caused these deflections to happen of these alpha particles. He said there had to be something heavy. The alpha particles were heavy and positive, and they had to hit something that was also heavy and positive to be deflected. If it was positive and it didn't hit them, it would push them out of alignment. They wouldn't be going straight because light charges repel. So that would cause them to be not going straight and hitting these spots on this side. However, if it was massive, it was big enough to push the alpha particles back almost to where they came from. The only thing causing this kind of deflection would be a large positive core, and that large positive core is known as the nucleus. So let's take a little bit closer look at Rutherford. This is kind of shiny, so I hope it's not reflected. So this is the overall setup of his experiment. Here we've got the beam of alpha particles, given off by a piece of radium. They all hit the gold foil, and some of them went straight through and hit that spot I talked about. Some of them were deflected, and some of them came back. And a zinc sulfide screen was the detector. So this little picture is a little bit closer. A lot closer, obviously, because we're looking at individual gold atoms. Gold atoms are very big. The nucleus is very tiny but very massive. So the alpha particles are these red lines going through, and most of them would miss the nucleus, because it's such a tiny thing. They'd go pass right through the gold foil. But some of them would get close to the nucleus, like this one, and go, oops, I'm positive, and it's positive, and I'm going to get away from it, and they'd go that way. Other ones would actually hit the nucleus and bounce straight back again. Which is what gives rise to our semi-modern model of the atom. It still didn't account for the neutrons that came later with work by Chadwick, and we're really not going to talk about that. You're just going to believe that the neutrons are in the nucleus. But that's what we have for the model of the atom.